Guten Abend. Es gibt mir froh, hier zu sein. Ich will auf Englisch sprechen. Brain and creativity. This is the main idea I wish to bring out. Creativity is about integrated brain function. It's about how the brain works together. So let's look at the brain relative to creativity. We have two sides to our brain. The left side has short-range connections. And it's responsible for numbers. It's responsible for language, for reasoning. The right side has more long-range connections. And what's that responsible for? Art awareness, imagination. And some people suggest even that the left side is where the scientist resides. The right side is where the artist resides. Some research looked at this. They presented people pictures of sculptures. And one sculpture was the golden mean, so the correct proportion between the trunk and the legs. Another one, the legs were longer. Another one, the trunk was longer. And they asked people to look at these and to judge which is most pleasing. And this is a part of the brain that was most active. This is looking from the left side, top down. You see it's actually on the left side. It's in the back part of the brain. The back part of the brain is where you create a concrete image. It's where you actually create a picture of what is happening. The left side is where you do analysis. So when you're analyzing pictures, that's the part of your brain that you're using. Now you may be a jazz pianist, and they had jazz pianists lying in a magnetic resonance imaging machine, and they were playing either scales or they were improvising. And these are the parts of the brain that were active. If it's blue, it means it's decreased activation during jazz. If it's red-orange, it means it's increased activation. And what you see is some parts of the brain are more quiet. Other parts of the brain, the front, this has to do with deciding your behavior, your approach, or your inhibition. And then we have the back part of the brain, which has to do with sound. So what's happening with jazz improvisation is this part of the brain, which governs sequencing, decision-making, is quiet. And you're really going by the flow. Part of the brain here, this is called the insula. This takes bodily states, it links it to emotions. So different parts of the brain, both front and back, left and right, are active during creativity. I want to give you an experience, a creative experience, and we'll see what parts of your brain are active. And that is, we have 9 dots. You need to see what's the minimum, the fewest number of lines. The lines all have to be connected that will go through all the dots. That is your mission. What do we think? 1, 2, 3, 4, 5. Can you do it in fewer than 5? Let's see. 1, 2, 3, 4, 5. What do we think? Four. Very quick. How do you do it?
I extend the line over the top of the...
Excellent. Excellent. This is the way to do it with 4. 1, and then when it goes over, it goes all the way to the end. So to solve this, notice you had to think out of the box.
He's an artist.
Excellent. Excellent. Well done. A successful artist, I'm sure. Now, if you try to do it remaining within these 9 dots, that's thinking in the box. The box that you're supposed to think out of is what's the problem space that you're being presented. You have to look at it in a new way. Can you do it with fewer than 4 lines?
3.
3. How?
It's only possible if it's really circles and not points, but starting in one corner and then going at a very high angle up, very high, and then going down to the 3 dots in the center.
Uh-huh.
the center column.
Oh.
And then,
Oh, sort of like this.
yes. And then going down through the center column, yes.
So that's 3, but we missed all of these.
Then we have to go down very far.
Uh-huh.
And then there's a very
Can we do it in one line? Can we do it in one line?
It's red.
They have to be straight. That's the one constraint we can't change. Yes.
Using a very big pen, you can just...
Yeah, use a thick line. Very good. So what creativity involves is challenging assumptions. And when they give people tasks like this, creative tasks, these are the parts of the brain they find are active. It's the front of the brain. The front of the brain is the last part to develop, and it takes what's concrete in the back and it puts it into a larger abstract symbolic space. We see that it's on both sides, both the left and right hemisphere. Because to be creative, you need holistic thinking. At the same time, you need point value. And you have to go back and forth very quickly. What are the constraints? What is the media I'm working with? How can I look at it in different ways? So what I'm going to be speaking about tonight is, well, first we'll look at how this works. The sensory information comes in here. Visual image is here, hearing is here, touch. And you actually combine these into a concrete image, almost like a film. That's where I am in your brain right now. And everything that I'm doing is just this film playing in the back of your brain. But just like a screen is unaffected by the film, so your memory is unaffected by what's here. To remember it, you have to use the front part of your brain. I've labeled this CEO. That's not a neuroscience term. It stands for Chief Executive Officer. This is the boss of your brain. Literally, all other parts of the brain send information here, and this puts it together. It puts together emotions, it puts together plans, it puts together prior experience, it puts together memory. And it's this integrated functioning of the whole brain which is critical for the creative task. So notice, this is the hub of creativity, and you may ask, what affects it? What affects frontal circuits? And that's what we'll be spending the rest of the time on. What affects frontal circuits, both positive and negative? Before I go on, are there any questions?
Could you please put this question in other words so I understand it better?
What experiences, what things that you do can affect how well the frontal circuits act?
Okay.
Was that better?
Fine.
Thank you very much. So one thing that affects frontal circuits is, and this is important for faculty who have students, is just development. Each dot here is a person. This is years. And here what we have is the number of connections. You have 100 billion neurons. It's like 100 billion individual computers. And you put these together to be able to see and think and process. When you're born, you have very few connections. And over the first 3 years of life, they become very high. Between age 3 and 10, the number of connections you have is twice that of an adult. So if you have a child who's 6 or 7, they're actually getting more input from everything they see. Beginning about age 10, there's a process of pruning. Connections become less. And the line doesn't go down to 0. It sort of looks at 40, you missed it. Yes. Actually, it levels out at about 18 or 20. And this is optimal level of connections. Now, one thought is there something you can do to stop this pruning? Is this pruning bad? And I'll ask you, does anyone here garden? Grow things? Yes, good. And do you ever prune your bushes? Do you ever cut branches off your bushes?
Yeah.
What happens after you prune the bush? It gets bigger.
Right.
Yeah. This is what's happening in the brain. For a bush, you cut off a lot of branches that are not very strong, and it lets the energy of the plant go to those that are there and becomes fuller. That's what's happening here. Your sense of individuality is emerging. You're getting rid of connections you haven't used, and you're strengthening those that you have. So that's one thing that's happening. A second thing is the nature of the connections change. They get a fatty layer called myelin. And the first areas for this to happen is in the sensory area. So when a child is 2 or 3 or 4, they're actually mostly working on being able to see the world and being able to move. So by age 4, a child can see the world as well as you or I. Then about age 7 to 10, the left and the right hemisphere become connected. This is through something called the corpus callosum. And so now the ability to see a specific and the ability to see whole is there. And this is where the child's thinking becomes full. The connections with the CEO only start at age 12 and they don't continue to age 25. And if you have 18 or 19 or 20-year-old students, you find that their ability to think symbolically, the ability to see a bigger picture, it's just that they think more concretely because these connections are not there. So this is development. Now you may say, well, what happens after 25? Yeah? So let's look what happens after 25. What we're going to be looking at is how the number of connections change throughout life. And what I'll be doing is just stopping it and starting it at different ages. Here's the brain looking at you. Now it's looking at me. Okay, just to orient. So here we have time. This is a color scale. And how it works when it's purple, like here, it means high level of connections. If it's red, if it's 1, it means very low level of connections. So watch how these connections continue to change. So this is 17, 27, 27, 57. That was 40. This is 57, 67, 77, and 88. So notice the areas which the connections are least are sensory areas. Well, this area, the CEO, and also here where you create a concrete picture, this remains pretty much high, even at age 87. And what's found is that the older you get, there's something that develops where you begin to see the bigger picture. A main difference between a new PhD and someone who's been in the field for 20 years is they go and they look at something and immediately they can see what's off. Because they've had so many experiences that they can, what they're actually seeing is patterns of data. They're not locked to the concrete experience. They're seeing larger patterns of data. So this is what continually is changing. And the connections that you have are very much dependent on experience. But before that, there's other things that affect experience. One is fatigue. Students were allowed to sleep, or students stayed up all night. And you know which group the student wanted to be in. Here they played video games, they played cards. Then the next day they laid in a scanner and they showed them pictures. The pictures started off very benign. There were trees and bushes. And then they became more intense. They became accident victims and burn victims. And they saw how is the brain responding. Okay, this is a part of the brain that's called the amygdala. This is responding, is activating 60% more. What the amygdala does, it gives a stamp of what's the emotional content of the experience. And what you see when you're overtired, your brain is telling you that the experience is very, very intense. And in addition, what's happening is when you don't have enough sleep, it goes to the primitive part of the brain stem, and just activates a fight or flight response. So that means when you're tired, everything makes you irritable. And yeah, exactly. When you're rested, it goes to the frontal lobes. When you're rested, whatever's happening, it's not so bad. It's easier to take care of. So if your roommate or best friend is irritable, you just know they didn't get a good night's sleep. Just let them go. Or you might even recommend they take a nap. Something else that affects frontal circuits is stress. What they did in this research, it was actually done with monkeys. The monkeys are in a cage and they watch the experimenter take a peanut, put it under a cup, and then they cover it over. In the no delay task, the monkey reaches out immediately, turns over the cup, grabs the peanut. And then in the delay task, they close the door and the monkey has to remember where the peanut is. And when, after 3 minutes, they open the door, the monkey reaches out, grabs the peanut, and eats it. They have two tasks. Here, where there's just a usual condition, here they have a loud noise. It's 100 decibel noise. 100 decibel noise is the sound in a soccer field, Fußball stadium. And notice, the more noise, even this mild stress, their ability to remember goes down. This is something that the frontal lobes do. Also, I want to distinguish between stress and challenge. Because oftentimes artists will say, well, I need stress to be able to produce work. And what I'd like to suggest is you're saying you need challenge. What happens under challenge is the core of the brain activates the whole brain. When you're under challenge, what happens is you actually see more precisely. When you're under challenge, you hear more clearly. The CEO, the organizing part of the brain, functions faster. We like challenge in our life. That's how we grow. We like challenge in business. That's how the business is most effective. Yes, sir?
What scope of challenge are we speaking of? I mean, if it's something that fundamental, activating things in the brain, is it more like more adrenaline, or can you see it in a longer scope, like a schedule or a deadline coming up in maybe a month?
All of those. And for some students, they start on their project 1 day before the deadline. Because somehow they don't put in their brain that the challenge is there a week beforehand. They have to wait till it gets really, really close, and then they stay up all night. And the unfortunate part of this is when you stay up all night, you're tired. And also what's happening is the challenge turns to stress. And what happens with stress is when you're working on your final project and you think, I'm not going to be able to get this done. This is too much. And what happens is the brain actually turns off the CEO. So your ability to have the big picture, your ability to remember the flow of your narrative in your film, it's actually gone. And what you focus on is each individual frame. So what I think the key to life, the key to success, especially in a creative field, is to be at a high level of challenge, but not to let it get to stress. And this is, fortunately, there's a very easy way to do that, and that is, our brain is a river and not a rock. And what that means is that you can do things to change this challenge-stress line. 70% of your brain connections change every day. So you may not realize it, but you're getting your brain rewired in your college career. What you're actually doing is putting your attention on composition, on light, on movement, and you're strengthening those brain areas that help you be good in that arena. Let's look at this generally. Michael Merzenich was the one who's done most of this research. And what he did on this is he looked at a chimpanzee, and you have a body map. So when you touch your fingers, you actually activate a specific part of the brain. When you touch your fingers, your hand, your arm, your shoulders, you trace out this figure in your brain. So what he did in this research is he touched the fingertips of the monkey with a vibrator for about 20 minutes, for about 3 months, and then he asked, how does the brain now respond when we touch the fingertips? And this is what he saw. Can you see what's happened? What has happened? A little louder?
Got bigger?
It got bigger. Thank you. Thank you for coming. It got bigger. Now, it's not as though your brain grows as you learn things and pretty soon you run out of room. But what it is you're allocating your 100 billion processors to different tasks. And the more you do something, the more of your brain you allocate to that task. And this allows you to be better at the task. We'll see this graphically. When you or I read, remember the visual system is the back part of the brain. We're looking top down. Here's the nose. When we read, this is a part of the brain that is active. What happens if you're blind? If you're blind, there's never any action potential going from your eye to that part of your brain. So what does your brain do? It uses it for something else. This is a person who's blind reading Braille. So this is touch. Notice, touch for the blind person is using what we use, but also it's using all of this activity, all of this brain area in the back. And that's how they're able to get so much information. Have you ever tried to read Braille? When I go into elevators, I always have Braille there, and I look and I say, okay, it looks like an L. And I can feel a bump, but I can't see an L. Because I only have a certain amount of my brain processing what's coming through my fingers. The blind person, because they're processing so much of what's coming through their fingers, they're actually getting more information. So if you work in film, or if you work in ceramics, or if you work in painting, what you're actually doing is devoting more and more of your brain to seeing that and understanding how that media works. And that's how the talent grows as you continue to grow. Now, this can have negative effects. I mean, all experiences change the brain. This is the effect of living in poverty. So this is the proportion of your life you've lived in poverty. This is looking at something called allostatic load. What's the effect of stress on the body? And when this goes up, it means the immune system is not working as well. It means cardiovascular system, you might have high blood pressure and so on. So the longer you've lived under stress, the higher this value. This is looking at working memory. Working memory involves the frontal areas. And also this part of the brain, it's called the hippocampus. These are actually smaller the longer that you've been living under stress. Let's look at another example. This is the number of violent films that you watch. And that's on this axis. This is how active that part of your brain is that tells you yes or no, that tells you that you should either approach or you should leave. It's called the orbital frontal cortex. And the more violent films you see, the less this part of the brain is firing. That means that brain is saying, it's okay. It's okay that this violence is happening. Now, when they did some behavioral data, they had a very violent film, maybe Terminator 2 or something. And as the people were coming out of the theater, they had an experimenter, a lady, on crutches across the street, and her crutches slipped and she fell down. And the researchers just timed how long did it take someone to go help her. And what they found is if you were watching a violent film, you were less likely to go help her. Fewer people went to help her, and it took a much longer time. It took 4 or 5 times as long. So this is what's happening with every experience. Our brain is it's a river and not a rock. It's being affected by what we put our attention on. It's also being affected by the situation. Okay, I want you to really understand this, so we have to pretend to be neurons. Okay, is everyone ready? So you have some constraints. You have to remain in your chair during this exercise, but you can move your arms around. What neurons actually do is they grow more arms. When two cells fire, what one neuron does is it branches out so it has more output, and the receiving one branches out so it has more input. Now what I'm going to do is this. I'm going to point this gentleman here. He's going to have to touch someone around him, and they're going to have to touch people around them. And what we want to do is pass this all the way to the back, both links and rex. So you in the very back, gentlemen, when you're touched, you can raise your hand. You could raise your hand now. Bitte, yes. So as soon as he's touched, he raises his hand. And also the gentleman there with the fluorescent yellow cap on, when you're touched, you raise your hand. So neurons, are we ready for this? Okay, go. Oh, renegade neuron, you have to stay in your seat, but it's okay. Remember where you're going. Oh, good job. Remember where you're going. Okay, remember where we're going. Okay, what happened to the right? We have a little left hemisphere advantage here. Now, but we forgot the right side. Okay, neurons. Now, that was okay. That's what it was like the first time you work with oil paints. And you put it on, it was just messy, and it smelled bad, and the colors mixed. Or the first time you tried to do a regression of statistics. It takes a little bit. In fact, when you do something for the first time, you use more of your brain. So now we're going to do this again, and now everyone doesn't have to be involved. We want to just get as quickly as possible from this man all the way to the back and left and right. Okay, neurons? You ready to go? Get go. Oh, yes. Okay, here we go, yes. Oh. What happened to the left side? Oh, we got some right hemisphere advantage here. Now this is better. Neurons, you're beginning to work. Let's try, I think we can do it. So we'll see if we can go very quickly from front to the back and both left and right side. Okay? Now there's a purpose for this, by the way. You'll see at the end. Get ready, go. Okay, let's see. Okay, back to the left. Yeah, they can do that. Oh, that's right. Go straight back. Did we make? Dankeschön. Okay. So notice, those of you on the outskirts here that weren't involved in this are thinking, Dr. Travis, let's move on. Those of you who are involved in the tap are probably really awake. You're really aware of everyone around you. This is what's happening in your brain. Every time one brain fires, it gets fed. It gets trophic factors. And it gets bigger. And it makes these connections. And so you know who's there. So when the information goes, you can make that connection. So this is what's happening in your brain. This is, the brain is a river and not a rock. And this is how meditations can help buffer the effects of stress and fatigue on the brain. Because
What does it mean, buffer?
buffer. A buffer means to make, soften, reduce the effect of, reduce the effect of, like that. And so the key point is meditations lead to experiences. And to say this, it's important to understand meditations are different. They're on a range of low to high cognitive control. Cognitive control is how much you're controlling the mind, you're focusing, you're evaluating what's going on. The highest level of cognitive control is focused attention. In these meditations, you keep your mind focused on one thought or one experience. You don't let the mind move. Example of this is loving kindness and compassion, where what you do is you create a strong emotion, a strong feeling of compassion inside, a pure experience of compassion. And it's the one thing that you're working on. Whenever you're focusing attention, this is what you see in the brain. It's called gamma. It's the name of the brain waves. It goes up and down 20 to 50 times per second. At this point, the person began this meditation practice. Now, gamma is, see, whenever you focus, gamma's going on in your brain right now. Here you're getting a brain lecture Thursday night, and it's maybe a whole new area, but it's interesting. You want to understand it. And so you're really working hard. You're blocking everything else out. You're focusing on what's here. So when you're doing any type of focus attention, this is what you'll see. Other types of meditations, open monitoring. Well, in focus attention, you keep one experience in your mind. In open monitoring, you allow experiences to go through your mind. The examples of this is our vipassana, or zazen, or mindfulness. And it's a process of dispassionate observation. You just observe what's happening without evaluation, without control. And whenever you're doing that type of process, that is, the mind is within and you're thinking, you're actively working in the mind, this is what you'll see. It's called theta. It goes up and down 4 to 8 times per second. And what they're seeing it is here and here. The third category is called automatic self-transcending. This is a category actually that I added with Dr. Scheer. These two categories were introduced by Anton Lutz. The self that's being transcended here is the meditation procedure itself. The actual steps of whatever you're doing, you go beyond those. This process has to be automatic, because if there's any evaluation, if there's any control, if there's any intention, that keeps the mind focused, it keeps the mind active. This automatic self-transcending allows you to go outside of thought, to go outside of categories. And whenever the attention is turned within and you're just awake, you see this type of brainwave. It's called alpha. It goes up and down 8 to 10 times per second. This is what it looks like, and notice it's over the whole brain. To just generally understand these different meditations, the meditation scriptures often talk about the mind is like a monkey. The monkey mind is always moving, it's always doing things. Now, if you want to control a monkey, there's 2 ways you can do it. 2 principal ways. One, you can run after the monkey. You can make ambushes for the monkey. You can try to surprise it. And these are meditations using focused attention. Or what you can do is you can put some bananas by your door, because monkeys like bananas. And if you have a pile of bananas, the monkey's going to come to the bananas. And then every time you open up the door, the monkey's going to be there. And that's what meditations and automatic self-transcending do. Yes, sir?
I've got a question regarding the brainwaves, because I never really got, are there just an observation, and one could link it to this states the mind is in, or is it discovered what purpose they have? I mean, is it like, is the rate of information processed, or do you know what that is?
Yes. First, how this whole process went through sequentially is we came up with these categories of how the mind functions. And then we asked neuropsychology, what are the brain waves when you see these type of mental functioning? And then we took meditation practices and asked what is published in terms of the brain waves seen during those meditations. And that's how we put meditations in here. And in terms of their frequencies, what gamma is, it's short-range connections, and what the gamma is involved with is object perception. You see Dr. Kubal walking. Just before you're aware, oh, that's Dr. Kubal, there's actually a burst of this frequency over the whole brain.
Yeah, but right now I still just have a correlation, and I don't know what does gamma do. I mean, what does it help me seeing him walk? Or how does gamma help me processing him walking or something?
How it helps is it's not so much the brain wave helps, but rather the brain wave indicates what the brain is doing. And when we see this brain wave, it means the brain is actually functioning in synchrony very quickly, so it can line up different parts of perception, vision, hearing, touch. You can tie it together with memory. You can tie it together with just a larger
really
form.
Kind of a processing rate. You have faster iterations if you...
It is processing rate, and this is especially processing rate of things outside.
Okay.
What we have with theta is processing inside. And what the theta frequency actually is produced from is a part of the brain involved in memory. When you're trying to remember something, that part of the brain produces theta, and it helps to block out other things, irrelevant stimuli.
So it's kind of a signal telling other parts of the brain to black out, or what is it used for in the brain? I mean, right now it's still just an observation that these states correlate with these frequencies.
What it's used for is when the memory part of the brain is oscillating in that frequency, it goes on and off 4 to 8 times per second. That helps it encode the memory.
Okay.
And alpha is when the attention is turned within.
So it's kind of a messenger.
Theta is, yes. What alpha is, I'm glad you brought this up, because alpha is a very interesting frequency. It's related to how big your brain is. If you have a big brain, the alpha is slower. If you have a smaller brain, the alpha is faster. And the alpha, the propagation velocity of the EEG through the brain is 300 centimeters per second. If you have a 10 hertz wave, it goes 30 centimeters when you have one wave, and 30 centimeters goes from here to here. So the alpha frequency is very much tied to the physiology of the brain, and it's the frequency when the brain is just keeping itself awake. It's not processing, it's not thinking, it's just awake, it's just aware. Yes, ma'am?
The EEG seems like an old machine. How come, or what is the reason why you're still using it, and how can it still trace all these different kinds of waves if it's just one machine? And what are the updates?
It is an old machine, and that's why we also look at neural imaging, but it has a number of advantages. One, you can get millisecond precision. The time is much better. With neural imaging, you average, for instance, 20 minutes together if you use positron emission tomography, or even 2 to 3 minutes if you're using, say, radioactive water. So oftentimes they use EEG to look at time measurement and neural imaging to look at space. A second reason is it's portable. You can't bring an MRI room anywhere with you. And though it's an old machine, it's getting at a fundamental functioning processing of the brain. Most of the improvements have been in the software to analyze it, and also in the software to be able to store it to large areas. And it does give quite reliable markers, especially of sleeping and dreaming. They still use EEG to look when you go to sleep, when you wake up. And so it still has a lot of usefulness in that way. So let's go more into this automatic self-transcending. I'll go through this quickly. That is, to understand this, see the mind as having a vertical dimension, almost like a body of water. These are like waves on the surface of the water, And these waves on the surface of the water are distinct and different, and they're analogous to our conscious thoughts. But where do our thoughts come from? There's first some quiet idea, some quiet hunch. Then as they develop in the brain, emotions, prior experience, prior memories begin to make this thought more full, and then it bursts on the surface. And what happens with meditations in the automatic self-transcending category, we'll be looking at one, transcendental meditation, is you start with a specific thought and you just follow it in reverse. You experience the thought rather at clearer and more expressed levels, at finer, at more subtle levels. And what is happening is the boundaries of the thought are becoming less, they're becoming secondary in experience. And the underlying field of wakefulness, which organizes thinking, is becoming more awake, until we experience a state called pure consciousness. Pure here is not a value judgment, it just means unmixed. It's wakefulness without thoughts, without content. So here's a question for you. What is this an experience of? So before, you're sitting there, you're aware of objects in the environment, you're aware of your body, you're aware of your thoughts, you're aware of your feelings. In the process of transcending, this awareness of things outside of ourselves, the awareness of mental objects is becoming less, till at some point you're not aware of your body, you're not aware of the environment, you're not aware of your thoughts, you're not aware of your feelings. What's left to experience? I'll get some tea while you're thinking. So what is this an experience of?
Of a dream?
Of
This is a sleeping state, or when one is dreaming or asleep?
Excellent. So let's look at this. In sleep, there's no content, but also your sense of self is gone. What this is, you're still aware of yourself. You're still aware that you're sitting there, meditating. And it's not dreaming, because in dreaming you have all these images, and there's no sense of self. But this is in the right direction. What is this an experience of?
Existence?
Again?
Existence?
Existence. Thank you. And specifically, the existence of who you are, your most fundamental level of who you are. It's not your social self, it's not your degree and where you are in the university. It's not your physical self, it's not your body, it's not your possessions, your car. It's not your mental self, your thinking, but rather it's your essential nature, that level of wakefulness which is always there. We ask, and this is what the brain looks like when you're having this experience. So this is functional magnetic resonance imaging. Here we have, it's red, increased activity, blue is decreased activity. So when you're just experiencing your essential nature, your inner core, your basic existence, your universal self, the frontal areas are more active, the CEO is more active, and the parts of the brain that are just automatic responding arousal are more quiet. And now remember, experience changes the brain. We started off asking what affects frontal areas. So what this is doing is having a positive effect. It's actually using those areas, and this increases the availability of this brain area for prior activity, future activity. Another way to look at it, in terms of relationships, here we have gamma. Remember, gamma is outer focus. This is during a task. The dots are where we record brain waves. There's a line if those parts of the brain are working together. We see, and the gamma frequency is where most of the brain is working together, and that's because it's an outer task and you're really focusing. There's some areas in the alpha. The beta, I didn't talk about this frequency. This frequency takes the pieces that gamma gives you and it puts it together into a whole. So now the person puts down their response buttons, and they close their eyes, they begin to transcend, and this is what the brain looks like. No gamma coherence, because it's not a process of focus. But notice alpha, notice this foundational frequency of the brain. High level of connectivity, left to right, front to back. So what's the value of this? The value of this is bringing the experience of our essential nature into our daily activity. I think we can see this here. This is someone who's been meditating for 4 months. Front, center, back of the brain. This is the alpha activity we talked about going all the way through. This is eyes open. What's really black like this is the beta, this is the gamma. This is the person watching, perceiving, thinking. Now what do you notice different between these two states and someone who's been meditating for 8 years? Again, this is TM, this is eyes open. Since someone who's been meditating for 4 months, this is 8 years. What do you notice?
Can you show it again?
Okay, this is 4 months.
One state gets much closer to the other.
One state gets closer to the other. This is experience changes the brain. This is the value of adding this experience of your pure existence, of that silent state of the mind, and then going out into activity and going back and forth. The brain actually begins to put them together. And what is putting together is the ability to focus and be sharp and see and think, but at the same time to have broad awareness. Same time to be very established in who you are. Who you are as an individual, who you are as an artist, at the same time as you're involved in the actual process itself. So, questions up to this point? Yes?
Talking about this pure self, but it's an interpretation, isn't it? So it's some kind of, I don't know. Where does this come from that you say it's the pure self in this level?
It comes from 3 things, modern science and also ancient records. I didn't show you, but we did a content analysis of people who described their deepest experiences during meditation. So in essence, how would you describe the state of pure consciousness? And then we did a content analysis. And what the content analysis showed that this experience was characterized by the absence of time, absence of space, absence of body sense. So what this is the experience of who you are when you're outside of time, outside of space, and when you're no longer identified with the body. And so, maybe pure self is not a good word, but it's often written with a S with a capital S, self with a capital S. It's that part of you that's most foundational, most fundamental. It's a part of you that doesn't change. Body changes in time, our thoughts change in time, but this fundamental level of the self is always the same, it's always there. And it's at the source of all of our thoughts, it's what's giving rise to our creativity and our intelligence. It's also said that just from the person's personal experience. I mean, when you experience that, it's just as though you stop being active and you experience this profound silence and fullness which is there. And over time you begin to experience that in activity. And this is in the direction, this is a hint of when we look at higher states of consciousness. When you can be completely in the world, completely active in the world, but at the same time your sense of self is not touched by what you're doing. It gives a new background for activity. So that's some of the reasons why we call it that. Yes, sir.
How do I know when you say that there's no presence of time and no space? Because I think that's nearly impossible.
It is, in waking state. Because waking experience...
But listen to my question.
Uh-huh.
How do I know? Take every word.
Uh-huh.
How do I know?
I know by being.
Well, that's just a game, huh?
No. It's the actual experience. Usually...
How do I know?
usually I know is because there's a knower and there's an object.
But then you have two. You have an observer. You're speaking out of the position of an observer.
Exactly.
It refers to that as an observation.
Exactly.
And that's
So,
an experiment's a different situation.
so if you can just let me finish.
Okay?
So when you say I know, it's simply those things. It's the knower and it's the object. In this experience of pure
I think
consciousness.
it's impossible to say I know. It's a common phrase. But okay.
Yeah.
May I answer that?
Okay.
Okay.
Yeah, if you think of the old words, I think that that's why I am. They have the only thing you can be sure of is that you are thinking. So I would say this is the very single thing you can be sure of. You can reflect about your experience and say that if I don't feel time, I don't feel time, and that's for sure. So this is not about the real time or the clock ticking or not. It's just about how I feel. And in the state, you can have experiences where you think, okay, I completely lost track of time. But so I again don't know where the link to the self is, because I would say I lose really everything, and that's myself too. So I would rather call it a reset maybe. So the brain finally has a rest and doesn't have to keep all these reflections from the outer world. So you really, yeah, I don't know.
And
you don't have to be a role or anything, you really are in your thoughts.
And the one thing to add to this, and I think this is a point you're trying to get at, if you're aware of that experience during the experience, and then there's obviously some content there. Typically the experience is after, you're aware of the experience after it happens. So meditation, there's some mental activity that you're experiencing, and then there's silence, and then mental activity begins again. And what the experience is that point is, I wasn't thinking at that point for some time, but I was there. Who I am, there was a continuum of being, a continuum of being which was there. There wasn't a break in my sense of self. What there was is the break in my mind thinking stopped, and then thinking started. But this experience of being there, of self-awareness, a continuum, wasn't lost. And it's an experience which, to impart by words, you can't get at, because words by their nature are very finite. But when you learn to meditate, this is the direct experience you have. And the way TM is taught, and I think just shows, it reflects on the experience, it's not taught with lectures. It's not declarative knowledge. Do this, do this, do this. It's procedural knowledge. What you do is you're given an instruction by a teacher, and based on that you begin to let your mind be quiet. From that you get some experience, and the teacher gives you another instruction, another experience. And what you do is you just experience what it's like to let the mind settle down. I sometimes say that learning TM is like learning how to ride a bike. I have 3 daughters. The way I taught them to learn to ride a bike is I didn't give them a PowerPoint lecture, and I didn't talk to them about balance and centrifugal force. We just got on the playing field, and they got on the bike, and I took their shoulders, or I took their seat, and I took their handlebar, and I ran around behind them, got really fast, and they experienced what it's like. To be able to transcend, that's the only way you can learn how to do it. It can happen spontaneously because you're just getting to the silent self, which is between thoughts. Abraham Maslow talked about peak experiences, and that's what he was talking about. Periods of transcendence, of unity, of oneness. It's there. With a meditation technique, you can get it systematically. And the value of getting it systematically is it buffers effects of stress. And I like to show you this. So this is a measure of brain integration, which is just how much of the alpha EEG during meditation is seen during activity. So it's a measure of how much of this brain signature is seen when your eyes are open. And the periwinkle blue students learned to meditate at the beginning of the semester. The plum-colored students waited till after the semester. So this measurement was taken just before finals week. I don't know if you have finals week in Europe, but In the US, you stop for a week and you have to relearn everything. You have big projects, you have big papers. It's a time of huge pressure, high stress. Remember what stress does to the frontal lobes. Fatigue, you stay up 2 or 3 nights. Again, what fatigue does to the frontal lobes. You don't eat good food. And this is what you see is the effect on a person's brain of finals week who's not meditating. We see decreased brain integration. It's just the impact of that ongoing experience on the brain. Those people who were adding this experience of their deepest self, we see that the level of brain integration is high even under that stressful time. And just to get a feeling for this, anecdotally, I would put on sensors, and it takes about 20 minutes, so I would ask them, how was your semester? And I was blind to group membership, but afterwards, if people said things like, oh, I learned a lot, and I can't wait to finish this paper, I'm putting things together, they turned out to be in the TM group. If the student says things like, I'm exhausted, I can't focus, I don't know how I'm going to finish, they turned out to be in the delayed start group. And this is the idea of the challenge stress line. And then we'll get to your question. If you can actively activate and use frontal circuits, they're more resilient. So you can take on a larger challenge. Another way to say it, if your sense of self is in terms of something silent and deep and calm within, you're able to handle much more chaos in the outside. Yes, sir?
Just to get this clear, the TM group is a random assigned group of people who were taught how to do TM or were, okay.
Yeah. So students randomly agreed to be part of the study. We did their pre-test, and then we randomly assigned them to learn TM right away or wait 3 months. And then we tested them again. Okay, there is 3 last slides I want to end with, and that is this brain integration. What value is it? I like to suggest it's money in the bank. What we looked at was world-class athletes. These were Norwegian athletes who consistently placed over 3 years in Olympic Games, World Games, versus control athletes. We measured the level of brain integration. This is measured during tasks. We see the world-class athletes have higher levels of brain integration. On one level, it makes intuitive sense. That is, if your brain is working more as a whole, you're going to be able to see the chances where you can put additional activity and win. Similarly with managers, top-level managers versus control managers. Top-level managers for 18 years, their companies continue to grow, and we also asked that they be socially involved. I didn't want managers like we had in the US in Enron, where they gave themselves $1 million bonuses while their employees were losing their retirement. I wanted managers who were good at managing a company, but also they had social conscience. And we see higher levels of brain integration. Again, it makes sense, especially in the world of management, because the whole environment is constantly changing. And so you need to have the ability to see the opportunity. Okay, this is important, I should go here. Your intuition needs to be strong, because if you wait to get all of the details of the economic climate, one of your competitors has come up with a product that you need. We looked at musicians. They were the same. These are amateur musicians and professional musicians. This is the joy of science. Now, the professional musicians were as high. The funny thing is the amateur musicians, why is brain integration high? And that's what the reviewers asked us. They said, oh, I guess your model doesn't work. Here you have the successful musicians, and their brain integration is the same as the quote-unquote unsuccessful musicians. Well, we looked in the... Yes, sir?
What does brain integration mean? Is it the whole working status? How much that it works?
What it means is not quantity, but quality. Is the brain working together? In essence, that number of brain integration quantifies what we see here. How much of this alpha activity is seen in the task? So that measure of when your eyes are closed and the brain is settled. Also, the picture we had of all the crisscrosses of coherence, that's actually one of the physical numbers that goes in here. But the fundamental point is just, is your brain functioning in localized compartments, or is the brain communicating with itself? Is it working together? Thank you. So one thing about musicians, as we looked at the literature, it's found that if you learn and practice music as a child, your brain actually is different as an adult. Because remember, your brain is a river and not a rock. And so as you're practicing music, you're using different skills. You're practicing the ability to focus. You're practicing the ability to focus on one sound and not other sounds. At the same time, you're practicing the ability, when you play with an orchestra, to integrate your sound to other sounds. All of this uses different brain areas. Now, what was different here is the professional musicians were higher on skills that were needed to be a professional musician. So what we suggested is this brain integration. What it's getting at is how in touch you are with your inner resources. And then that's what you can take and focus in whatever is your job, whether it's art or business or science or whatever. And that's why the amateur musicians were very successful in what they were doing. IT, pharmacy, education. It's just they didn't make their money from music. But they loved music and they were good enough, they actually took their time to do it. Okay, last group is a group of engineers. These are aerospace engineers having to, and this was actually looking at creativity and brain integration. And this gives sort of a big picture of the whole lecture, that brain functioning can affect success, practical success, and also by systematically transcending, you can increase the level of brain integration. So our next research is to take junior athletes, junior musicians, randomly have some of them begin TM practice, and what we expect is their brain integration will grow more than the control, and they also will grow more successful than the control. So I'd like to leave you with this picture. Good. Any questions?